All right, welcome everyone. Going to give folks a few moments to join. We'll do a quick intro and then we'll go ahead and get started with today's presentation. All right, looks like we've got a good amount of folks starting to trickle in, so I'll go ahead and share my screen.
Uh-oh, do we lose Bo?
We're back. Oh, so sorry. It looks like my Wi-Fi just cut out for a second. Can everyone hear me okay?
Yep. Yep.
All right, great. We're back. Awesome. Okay, perfect. Sorry about that, everyone. Cool. Thank you so much for joining today. And we are going to have a great product presentation from the folks at HushFrame today. Everyone at Acelab is super excited about this product. It's really solving a lot of very real issues in the industry. So we're going to learn some great new product information today. Before we jump into that, I just want to show y'all how to get in touch with today's presenters and access some more information if you would like to dig into some of these products a bit deeper after today's webinar. So from Acelab's homepage, there's a ton of free resources that you can use here. I'll drop one of my colleagues' meeting links if you want a free demo in the chat momentarily, so you can reach out, set up some time to get all set up on Acelab. What I want to show you today is just how to get in touch with a manufacturer, explore some more about their products if you know exactly who you're looking for. You can always use this search bar at the top here, type in the name of any brand. It'll cross-search between product categories and resources, so just make sure you're on that brand tab. Head over to their page on Acelab. From here, you can reach out to them directly. You can explore some more about their company, watch some videos, as well as explore their products and save them to your projects. So this is a great place to come after today's event if you want to view some inspiration, get to know the product and the company a little bit better, and get in touch with their team directly. Last thing I want to show you here is just our conversation feature. So you can communicate directly with manufacturers and vendors through Acelab system. Works really great as a way to kind of keep your communication all organized along with your product data. So if you let us know that you're looking to get connected with HushFrame after today's webinar, someone from our architectural support team is going to help you out with making a connection over here in your Acelab account. You can just head to that little connection button at the top. You can see all of your conversations here, so you can follow up with them through Acelab's platform. You'll also get an email notification about any new messages that you get through Acelab. You can respond directly to those emails, and that'll log in Acelab's platform as well. And actually, real quick, just want to show everyone a little aspect of this is currently an early access feature. So it's not publicly available to anyone, but if you are interested in getting set up with this kind of new view in Acelab, you can reach out to our team and we'll help you get all set up here. This is our schedules feature. So it works really great as a way to keep that communication organized, get your rep stored in here, as well as bring in Acelab data points and all of your own custom data. So you can really organize your products in your digital firm library, have it fully collaborative and accessible with your team, and customize it to work for you and your firm. So if this is something you're interested in getting some help getting set up with, our team provides free support to be able to help you load all your products in here, get this all up and running, and be able to kind of, keep your product research, your communication all organized in one place. So keep your eye out in the chat. We'll send over some helpful links to these pages on Acelab, meeting links for free demos. Feel free to grab anything from there. Last thing I want to mention is to please feel free to ask questions throughout today's presentation. You can do that using the Q&A box. We'll keep our eye on those. If anything is super urgent, we'll get to it in the moment. We should have some time to kind of talk through all the questions towards the end. And if we don't get to your question live, we will have a record of it so you can be followed up with after today's event. All right. I think that's all for me for now. Thank you everyone for joining today. Without further ado, I'd love to hand it over to Micah to get started with today's presentation on HushFrame.
Well, welcome everyone. My name is Micah. I am the CEO of HushFrame, and I'm excited to present to you the presentation with the co-founder and Chief Innovation Officer at HushFrame, Alan Case. And today we're going to talk about how you can maximize STC and IIC performance in your wood frame construction assemblies. And so we're going to do this all without the addition of cementitious toppings. And without further ado, Alan, I'm going to turn it over to you.
Yep. Hi, everybody. I am Alan, and I am the inventor of the HushFrame product. And I'd like to show you what it's all about and what it can do. And we all have noise issues, and we look to address that. So this is a next generation product in the sense that all historically hush, sound isolation has been dealt with primarily with metal-based products or cavity insulations, and they have issues that don't really present themselves until the building is built out, and then people move into the place and they realize, oh my God, it's not working. So we've discovered that decoupling is really the only way to get this done. And so we've invented a product that separates the gypsum wallboard from the structural frame and traps the noise energy so it can't transit through. And the core of the product is this is what they look like. Small wooden devices that screw to the side of studs and joists. Furring is attached to this face. And as the energy is traveling through the structure, it has to enter this silicone compound in the center. And it just dissipates as a little bit of heat because it bogs down from the viscosity of the silicone. Decoupling historically has been done by building double stud walls or suspended ceilings, things of that nature, but they all have issues. So we can address those directly. The double walls are effective, even though we do outperform that with a single stud situation. But the biggest problem with double walls offer is they eat up a lot of floor space. And now it's the cost of construction is so high, and losing 3 or 4% of your floor space to an unnecessary second petition is something that's really frowned upon. Suspended ceilings really have gone the way of the Model T car. They're used primarily now in industrial and commercial application. They're effective, but they are expensive, and spring hangers and all sorts of things get involved, and Chicago style, and it's just something that's not desirable. Resilient channel, which was brought into the market back in the 70s, is extremely popular. It's used ubiquitously across wood frame construction, but it has real problems. It's not very effective in the sense that you're transferring the noise energy into a long strip of metal, which is transferring it pretty directly to the gypsum board, and those installers of the resilient channel tend to carry. It's usually installed by the gypcrete or the drywall subcontractor, and they carry typically in their pouches 1 1/4-inch screws. And so the resilient channel is installed across the stud or the joist face, and then when they hang their first sheet of drywall on it, they're using 1 1/4-inch screws, the channel only being 1/2 inch thick. The screws are traveling through and attaching themselves to the structural frame, which short circuits the installation. And USG, who invented the product, suggests that from their investigation that up to 80% or more of the installations are failures. And so field testing is showing us that it's really, really a nightmare. The metal clips have problems with, as we just talked about, short circuiting, but they also suffer from the fact that when you use hat channel or resilient channel in your ceiling, you can't attach mechanical devices to the metal channels. They have to make light fixtures, things of that nature. Everything has to be attached back to the structural frame, and that it's like creating an air conditioning system in your living room and then just leaving the windows open. It creates a flanking path where the noise just travels right across the frame and into the fixture, and then right to the surface of the assembly. Composite gypsum panels. You've all seen that stuff. It's some of them weigh 300 pounds. I mean, it's incredible what they have out there. But they're primarily designed for walls. You can't use them in the ceiling. They're ineffective, and they certainly can't be attached to any metal product. They're too heavy, and then the screw problem with the overloading fasteners and creates deflection, and so the manufacturer tells you you can't do it. So there's no escape for the noise there. Damping adhesive, we see it. You see green glue and some other products that are on the market that they use to fasten, or not really fasten, but to add a damping membrane between two gypsum panels. They offer really very, very, very little performance. And again, they suffer from short circuiting because those panels have to be attached to the framing. And when they go through, the screws are, again, there's like little loudspeakers for every screw attachment, so that it doesn't decouple. It's still providing a path of travel. And then when you do have a decoupled system, it offers absolutely nothing. So there's a real misunderstanding about cavity insulations. Noise travels through in two different ways. So you've got structure-borne noise and you've got airborne noise. And airborne noise, when it's in the room, once it hits the surface of the assembly, like your floor, it becomes structure-borne and it travels through. And what it wants to do is come off the back side of that subfloor panel, be it plywood or whatever it is, and it wants to move around, just resonate, bounce around inside the cavity, and then go to the back of the drywall on the opposite side of the assembly, and then escape into the room. That's called air spring. So all you need to do is to control that, is to put soft isolating material inside that cavity, and nothing outperforms just unfaced fiberglass bad in the laboratory, and you solve the air spring problem. The noise moves through air at 1,200 feet per second, but it moves through the wood framing systems at 12,000 feet per second. So the noise energy is really, it's all in the frame. And so that really shows you that you gotta work with the decoupling to get it off the frame. And then the mineral fiber and the slag materials, they actually are so dense when they're stuffed in the cavities, they actually create a bridge that sometimes noise crosses over, and they underperform softer materials. That is not to say that they don't have a great thermal value, which I'm sure they outperform the fiberglass in that regard, but it's, we deal with acoustics.
So, Alan, maybe we can talk for a second about some
Yep.
of the things that we've actually heard when we've dealt with some builders. For instance, the assumption that the more rigid the insulation that they used, the more deflection of sound that they would achieve. And then we were able to kind of turn that on their head by what we found in the lab.
Yeah, rigid insulations are an absolute nightmare. Particularly a closed cell foam or something of that nature. You're just turning the space into a drum. Noise, there's absolute no absorption or control of noise, vibration, energy. It just travels through. You're making the entire assembly into like a solid panel, and it's just they're screaming loud. There was a woman in Boston who spent $4 or $5 million on this gorgeous brownstone project where she was creating 3 condominiums, very high end, and to control noise, she was so paranoid that she had every floor, every joist cavity, every stud cavity, and even in the rafters, she had everything shot and filled with rigid foam, and they basically had to go in and gut the building. She completely misunderstood, and the insulation contractors don't seem to know what they're talking about, and they very bold-faced, openly sell this stuff, and they market it, and they say it's going to control noise. It's the exact opposite.
Yeah, so let's talk a little bit about some of the legacy products that have been existing on the market, and some of those decouplers, and what the difference is. Some of this, what they intended to do with their designs, and what actually the result is.
So in late 1970s, USG invented the first metal furring channel. They called it resilient channel, and they exited the business 10 years later once they realized what a failure it was, and how poorly it was being installed and how they had no control over it. But it's now, as I explained, it's ubiquitous. So moving from that and looking for, again, even more efficient decoupling, you have the manufacturers have created these sound isolation clips. They come from 5 or 6 different manufacturers, and they all basically have the same concept. They have a polymer ring or pad you screw through, and that isolates the metal frame, and then you have your metal hat channel that snaps in, it nests. It's not mechanically fastened to the devices, and they're pretty efficient. They do well. We outperform them just a straight up in an installation, but they have some weaknesses. Number one, again, you can't attach your mechanical devices to the furring, so you're allowing all that flanking to occur in the system, and the Sure hardness of these polymers that they're using in here are as high as 70 and 75. And what that is that means it's a fairly stiff rubber or stiff plastic, which doesn't really stop the vibration energy so much. It has some effect, but it's not that efficient. The silicone core in our product is a Sure 21. It's almost like an elastic band. The reason why they're so durable and so reliable is that we use such a mass of it in our decoupling devices that they just eat all that energy.
There's
another
also
issue you
some
have
pragmatic
Go ahead.
concerns, boots on the ground, right? Where what we've heard from actual workers on the ground who have to snap in those metal channels into some of these clips, where they suffer the hand fatigue from going from clip to clip as well, right?
Yeah, they're hated. They're hated. They're absolutely hated. If you can give me the next slide. Okay, get to that. My slide's not changing here. There we go. Yeah, so that's how it's done. You have to squeeze the hat channel to set them in the nest, and it's not as simple as you think. They're quite stiff, and this guy's wearing heavy gloves to do it. But what you'll typically find is they're actually using a big pair of water pump pliers or things like that to just squeeze it down. And when it does that, it sort of crimps the channel, and they don't sit quite as tight as they could, and they vibrate, they bounce around. So I mean, the wall is not, it's not a perfect situation, and it really runs into trouble when you get into fire code issues.
Excellent. So let's talk about the disconnect, the big disconnect here. We know that. Let's talk about UL rated fire resistance requirements for floor ceiling assemblies and how they complicate acoustic control efforts.
Okay, so the metal channels and the metal devices do not fare well in fire. They have a real issue with fire. What happens is you go in, and to obtain a 1 hour fire resistance rating from UL, you have to build your assembly inside one of their furnaces, and it has to withstand an open flame at 1700 degrees for 60 minutes. The metal tends to really respond to the heat, and it warps, and the panels split open, and they've got issues. And so to control that, UL requires, if you're in a fire rated assembly with these devices, that you have to put them in such an intense constellation that they can hold the channel to the frame while it's burning, basically. And so the manufacturer of one of the clips will tell you that you should space them 24 inches apart in rows, and then every 48 inches along, skipping every other joist or every third, depending on what your framing layout is. And so in a 12-foot by 12-foot room, you would need, under that formula, you would need 28 of their devices, and then the running lengths of the hat channel. And that's the assembly that they will test in the acoustic lab and publish on their documents and on their websites, telling you this will have an STC 58, or this will have an IIC of 60, or whatever it is that they're advertising. What they're not testing or showing is what the actual assembly looks like once it passes UL, and we're talking UL L521, L528, L576, the standard basic floor ceiling assemblies that work with trusses, wood trusses, small wood trusses, and there's such a disconnect in the performance, and so no one is showing you when you have so that 12 by 12 foot ceiling. If you have insulation material that's over 3.5 inches, that's not stapled to the underside of the floor, you'll have an issue with UL. So they require, if the insulation is not 3 inches of insulation, anything greater than 3 inches of insulation that is not suspended in the center of the bay. If anything is larger than that, and we start with a minimum of 5.5 for acoustics, and if it touches the backside of the ceiling membrane, then you have to tighten the panel, the spacing of those devices down to the point where on a 12 by 12 foot room, you would have to use 24-inch spacing. You would use 91 devices, and on 16-inch spacing, you would use 130. Which
so let's I want to just kind of nail down here on this disconnect. Why is it, in your opinion, that architects there's a disconnect between them being able to actually or just the information flow that gets to them? Where's the it getting lost in translation? Where, for instance, they're trying to achieve the fire rating, they're using these conventional measures, but then obviously those conventional measures are causing them to also lose their ability to provide acoustical privacy. Where exactly is that getting lost?
It's getting lost in the fact that there's been no testing. There's no published testing of what those constellations of installation look like in the field. The manufacturers are saying that product installed in that ceiling will produce X STC or X IIC, but that's based on an ideal laboratory structure, and it has nothing to do with what is actually being built in the field. And so that's all they publish. And so the architect will look at it and say, oh, this says it conforms to UL 521 or 528, when in fact, if they actually read UL 521, 528 and looked at the spacing, they would realize that it has absolutely no relationship to the acoustic representation from the manufacturer. It only shows itself in field testing.
Yeah.
And
so one of the things that I'm sorry.
Go ahead.
Yeah. One of the things that we looked at HushFrame as well is that we looked at trends in construction, because trends in construction is just as important. What did Wayne Gretzky say? He said, I didn't skate to where the puck is, I skated to where the puck is going. And so when we were bringing HushFrame to market, one of the things we talked about was trends. And so some of the trends that we identified was that there is a trend towards more sustainable wood frame construction. And no doubt, as an architect, you've seen these trends in wood frame construction kind of pop up. You've also seen that there are more lighter, more contemporary materials that are being put into buildings. And there are more people in these densely populated multifamily buildings that are being converted from renting to housing to actual condo owners. And the condo owners, there's some major issues here with these owners who are going into these condos, and yet they, about after, I don't know, maybe 30 to 90 days, are starting to, complain about the noise issues. And so one of the things that HushFrame actually fights against are these individuals who are in these, what were once beautiful apartments, but don't meet code because of the materials. And then we kind of come in and we do that. And tell me a little bit more about the housing trends that you've seen in the applications with HushFrame, how that works.
So it's all wood frame. It's most of the stuff is 4 or 5 stories over a steel or concrete podium, and they're dense. They're 50 to 200 units in the buildings, and it's it's all light wood truss and engineered panels, and the stuff is it's really loud because it's so light. And back in the 1960s, you had old growth lumber, and the stuff was, and you had your ceiling would be wire and lath and plaster, and it was very, very dense and thick. And noise wasn't so much of an issue, but the stuff we're building now, again, like I use the drum analogy because it's incredible how loud they get inside. And so the builders are finding that the simple inclusion of HushFrame in the walls and floor, particularly floor ceiling assemblies, stops the transit completely. You don't hear the person upstairs. And we have with the UL M565, which is our proprietary design with UL. All you're required to do on a 12-inch truss is put a single sheet of 3/4-inch subfloor on top, and you've obtained, with the HushFrame in the ceiling below with wood furring, you've obtained your 1-hour fire protection, and you also come out with the highest performing IIC and STC of any product combination in the industry.
Right. And one of the major things that we've actually seen is getting called from into individual builders who are now getting sued or
Right.
who have complaints, civil complaints against them as a result of the noise litigation that's occurred due to improper construction or meeting code, just missing the code. So we know that homeowners association and litigation noise complaints are exposing some of these products that weren't tested well, and that, as you mentioned earlier, failed to actually show the results of their testing because they probably were embarrassed by it, which, surprise, surprise, right?
Right.
But now we're starting to see this actually come to bear, and it's really expensive for these builders to mitigate the sound issue after the fact.
Well, it's a tragedy because we have 3 or 4 fairly big projects in Boston that are going through this right now, and they don't like to talk about it. And once it's discovered, what the homeowners are, what they're doing is they're hiring law firms, and there's a couple law firms now that have caught on to this, and they've caught on to the developers that have these problems, and they're kind of pursuing the HOAs, and then they're bringing in a field testing company for acoustics, and they're showing that they most often squeak by on the STC on the floor ceilings, but they're failing miserably in the IIC on the impact noise, which is what drives everybody nuts. You can hear everybody walking around to the point where the code requires specifies a minimum of IIC, if it's tested in a lab setting, 50, and they allow for 45 if a field test. But the highest one I've seen tested that's in litigation came in at a 38 in field,
Right.
which is just miserable. I mean, you have a 38, you can't even, it doesn't even block intimate conversation. It's
That's
pretty
exactly
amazing.
right. And we have
Yeah.
a very simple principle. So working from first order principles here, if you control the vibration, you control the noise. And that's the
Yep.
point. And that's what we
Yep.
do. So we work on STC, the sound transmission class. We work on the IIC, the impact insulation class. That's our goal. Our goal is to control the vibration before it gets to the other side. And that's why HushFrame is here. That's why it's what we consider the next generation context solution. And so, Alan, talk a little bit about how HushFrame can eliminate the need for complex construction assemblies.
Well, it's that simple. It's so, as you'll see later in this presentation, there are a couple of slides that'll show you a floor ceiling assembly with a 14-inch truss that's built with RC in the ceiling below, and the top has it's filled full cavity with mineral fiber, and then it has on top of the 3/4-inch plywood subfloor, it has an acoustic pad. Then it has a gypcrete or a cementitious gypsum concrete on top, and another resilient pad, and then a finished floor hardwood that's floating. And just the simple HushFrame installation with 3/4-inch or less, half-inch hardwood floor sitting on the 3/4 direct outperforms it by nearly by 9 points in the IIC and 8 points, I believe, in the STC.
Right.
It's literally half as loud, and for so small cost, so much less expense. You don't have to do it. You don't have to bring wet concrete materials into a wood frame building. It's a mistake. The
From the
reason
marketing, I'm sorry.
the reason
Go
that
ahead.
that industry developed it is because of resilient channel and the problems the resilient channel has. Not as much acoustically, but from the UL perspective. UL requires that gypcrete topping. Otherwise, you're going to get a burn through for the firemen. So it just adds that the complexity of those builds is just unnecessary. And not only is it unnecessary, but it far underperforms what you can do with a much simpler application by ignoring all those products and simply putting HushFrame in your ceiling.
Now, we say that we offer a superior acoustic performance over all competing technology. There's a lot of products that actually make that claim, and they make the claim, as as we found out, generally counting on the fact that people won't actually research to try to figure out if they are superior. And so,
Right.
can you explain why we can actually make the claim that we make in the slide, and why it's important for architects to actually key in on HushFrame and what we use for technology?
The simple answer is because we field test. We go into these buildings that we build, and we bring in an engineer at the end, and we get certified field testing from an acoustic firm, an engineering firm that backs up the performance. And I mean, it's that simple. We can show you literally. We're not showing a manufacturer's brochure of what they're doing in an idealized setting of a laboratory. We're showing you these buildings that are on the streets of Boston and other cities where this stuff is in the walls and it's in the ceilings and it's field tested, and it's actually outperforming some of the lab testing because
Right.
the installation is so effective.
Absolutely. Now let's talk about fire protection, because this was really exciting actually when we got this UL issued. This was
Yep.
really a game changer across the board. Talk about M565, because this right here is literally, in my opinion, historic in the construction industry.
Yeah, it really is. And so, as I explained earlier, the metal channels and the metal connectors in the ceilings in the fire chamber react really poorly. They twist, and they allow all kinds of stuff to go on. So, like as we talked, the stuff has to sit. These assemblies have to sit in the furnace for 60 minutes at 1,700 degrees of open flame. So you get two tests. You get the fire resistance, which once you have the 60 minutes, you have 1 hour, and then you have what's called a surface rating, which is the time on the clock from the beginning of the burn till when the panel membrane on the ceiling first opens and allows that flame to enter into the interior of the assembly. So under L521, 28, 528, and 576, all of those constructions with whether all these manufacturers that we showed you earlier are involved in those testings. Those surface ratings are all 22 to 25 minutes. And then the ceiling, because of the metal, even with that constellation that UL requires, that stuff opens up and the flame is in the floor. Our surface rating on our M565 with just the HushFrame in the ceiling and wood furring is 64 minutes. So it went beyond the 1 hour test before the panel even started to open and allow the flame to get into the assembly. It so far outperformed, it's so secure that it was shocking to the UL engineers who thought the stuff, the silicone, was going to melt. It doesn't melt. It thrives in heat. It absolutely thrives, and it's pretty incredible. So, and we did one of those tests in the UL lab with metal furring on HushFrame, and I think it was a 44-minute surface rating. But when the test was over after the hour, we took the fire hose in, opened the chamber, put the fire out, and looked up at the ceiling and the trusses. Everything was burnt crazy, right? But the metal furring was still in place, hanging from the HushFrame.
Right.
The
That was a
burnt
source
around.
of pride for us. We still have that picture in our factory too.
Yeah, and
So let's
it just
talk
shocked the engineers. Yeah.
It did. Let's talk about some advantages here. We see the questions coming in, and we will answer them. We'll get to all of them at the end when we get to the Q&A. We're going to just kind of talk a little bit about the advantages again, just so that we can crystallize for you what some of these advantages are when you go speak to or when you designing and when you speak to your clients. It's important for you to be able to also talk about the advantages of a HushFrame. So very quickly, Alan, talk about like in a bullet point fashion, what are the high level advantages of installing HushFrame RAV connectors?
I mean, the simplest is it's extremely simple to install. It's a couple of wood screws in the side. Wood furring is next. Very simple, a single screw into each connector. it's so easy. It's cost saving. It's inexpensive, and it's environmentally friendly. I mean, it's just
Right.
it just
We
hits.
eliminate the need for gypcrete, given our fire rating, that you just expounded on, and
And
at the same
it,
time, we're giving the acoustic rating immediately that they need. And our field tests have been so tremendous in terms of how they've performed and outperforming the lab, um, uh, in quite a number of applications that we can actually show.
yep. Yeah.
Um, yep. Go ahead.
So we've in the UL we've hit across the board. Every type of wood framed assembly that you would use in a building, whether it be single stud, stagger stud, double stud, shear walls, exterior bearing walls, interior, even metal. And we've got UL design for an hour in all of those assemblies. And simultaneously, with those builds, we also have the highest STC performance in all of those assemblies right across the spectrum.
That's right. Very good. Now, field testing, that's really, as you can imagine, a resident's ear test is usually a field test, right? So once they go into their unit and they're sitting there with their family and they're hearing the neighbor, it's too late once they put that beautiful plaster on the walls and they have all their furniture in.
Yep.
The reality is that the boots on the ground result that we look for in a properly installed sound decoupling technology are field tests. And HushFrame is the king of field tests from where we sit.
Yeah, and not only just field testing, but also lab testing. We have tested so many assemblies and so many other products in the acoustic lab, primarily at Riverbank, and which is the premier in the U.S. in Geneva, Illinois, outside of Chicago. They believe that we have done more testing than any other manufacturer of any product that's in the acoustic market.
Right. So we know that HushFrame assemblies exceed the performance of the more complex assemblies that include RC, that include gypsum or cementitious toppings, and then of course multiple layers of underlayments, Matt. So like it's really important to understand the cost savings across across a massive project, 200-300 unit buildings. I mean, we're saving these building owners hundreds of thousands of dollars or more and more.
Yeah, and it's not just the material cost that you're saving them. I mean, the metal furring is expensive. Certainly the cement toppings and the resilient padding is, all extraneous. You don't need to do it, but it's more than that. It's also project delay. Put down a cement floor like that on top of the wood frame. You have to empty the building completely. You got to pour it. You've got to let it dry. It's just you're introducing all that moisture into a wood building where you're bringing in potentials from mold and all sorts of things, and it's just so disruptive. I mean, just having to empty the buildings down and vacuum them to do this is just it's so ridiculously disruptive that it's one of the things that the wood frame guys want to get away from first is how do we get away from gypcrete? How do we get away from these toppings that are just clogging the works?
So you put together an interesting assembly cross section here with resilient channel and the gypsum concrete performance.
So this is
want to explain
the
first one?
Yeah, this is an actual building that's in Quincy, Massachusetts. It's 50 or 60 units. And the developer said, well, we're thinking about HushFrame for projects going forward. We've just finished this building. And I said, well, what's in the floor? And he explained what the construction was. And I said, would you mind if I field tested it? He said, no, if you don't, as long as you don't publish the address, if we have an issue, if we have a failure, we don't want it to, so we have a confidentiality agreement with him. Went in and field tested this building, and this is the construction that it was. It's a 17 3/8 inch deep assembly, and it field tested with a STC or a airborne at 53 and structure borne at 50. So that would be in the lab 5-point upwards or adjustment up. And so you would have a lab IIC of 55, which is 5 points over code, which is good. It passes. It's not ideal. It's still somewhat noisy, but it passes the legal requirements. And then you take the next slide and you'll see a HushFrame assembly. Okay, and here we are. This is also in a Boston building where it's the same depth of truss, and they both have full-blown cavity insulation, soft insulation, so that's not a problem. This one has a 1/2-inch engineered wood that is glued and stapled to the 3/4 subfloor, so it's rigid and noisy. And then you have HushFrame, wood furring, and 2 layers of gypsum on the bottom, and it outperformed the Gypcrete and RC floor system by 9 IIC points, which
And if you're
is
looking at that
literally
cross section, it's obviously the little blue HushFrame that's been highlighted there. You can see the furring attached to the HushFrame.
right. It's so outperformed the more expensive assembly that, and you can do anything you want on the top. You can be ceramic floors, ceramic tile, cement board, whatever you like. It's not gonna kill you. It's not gonna drop your rating.
So Daniel asked a great question. He asked, do you have any installation details, or can you share or present here? And the answer to that question is yes, we came prepared. I'm going to click on this video. If you're watching this presentation, this is a video, and let me make sure I'm sharing my sound, where you're going to actually be able to see.
Yeah, it's less than it's less than 3 minutes. So
okay, I'm going to share. This is the installation video. You're not going to be able to. I can't share my sound for whatever reason, but you'll be able to see it here.
They can't hear it?
They can't. But I'll make it big so you can see it. So Alan, maybe you can just talk them through the installation as it's showing here, because we don't have sound.
So it's playing on my computer.
Oh, you get the sound?
The sound is playing on my computer. It was, yeah.
Okay.
So it's silent, Micah?
To me it is, but if you can hear it, that's fine.
Are you there, Micah?
Oh. Front of the framing face.
I'm sorry. Are you there, Micah?
I am.
Yeah, it's I'm kind of in a box here because if I shut off my sound, I won't be able to communicate with you.
That's okay. Bo, do you want to chime in here?
Yeah, I was just gonna say I wasn't hearing the sound on the video, so it does seem silent too.
Okay.
To me.
Let me do I have to, maybe I have to reshare, stop reshare, and then
I think you might have to reshare and click that optimize for sound.
No problem. You have to, everyone here will have to just look at me in my face for a minute, but that's okay. Enjoy.
All right, let's see if this works.
Introducing HushFrame decoupling rafts. HushFrame raft connectors are sound isolation devices which decouple and isolate drywall from framing members. HushFrame rafts consist of 2 wooden sections connected by a vibration isolating and noise killing core made of pure silicone. The long narrow section attaches to the framing members, and the long recessed edge aligns with or protrudes slightly in front of the framing face. Sound waves inside the room are absorbed and blocked by the silicone cores, dramatically reducing the sound transmitted through the wall. As the viscous drag provided by the silicone core provides mechanical isolation. HushFrame UL Design M565 is the only 1-hour fire-rated wood-framed floor ceiling assembly that allows for use of wood furring in the construction. A typical installation grid will have the raft spaced every other stud horizontally and every 2 feet vertically. Ensure the raft faces are all aligned in a flat plane. The rafts can be adjusted forward but not backwards to correct alignment of deflected studs or joists. Run a string or laser line up to the rafts. Use shims to correct mounting on twisted framing. Fasten each raft to the framing using 1 5/8 inch bugle head screws, 1.5 inch long medium crown staples, or 6-penny ring shank sheathing nails, driving 1 fastener through the center of each leg of the longer section. 1x3 wood furring strips are typical. The furring is typically installed perpendicular to the framing members. Fasten furring to the raft using 1 2-inch or 2 1 5/8 inch coarse thread bugle head screws. place the screws in the center 2/3 of the raft. Leave a 1/4 inch gap at ends or sides of furring rows for optimum noise isolation. All mechanical devices should be attached to the decoupled furring to prevent short-circuiting and flanking paths for noise. For top performance, fill cavities with soft insulation. Hold the perimeter of drywall back 1/8 to 3/16 inch and fill the perimeter with non-hardening caulk. With HushFrame, you get superior acoustic and fire-rated performance without the need for gypcrete or resilient padding, just double 5/8 inch drywall panels for top STC and IIC results. For more information, visit us at HushFrame.com.
All right.
Whatever you do it for less.
All right, so a little bit of a Ford commercial there at the end, but I think you all get the point when it comes to how to install this. I hope that answered your question, Daniel. And very quickly, we had a case study of condos from Florida, and they were going through a challenging noise situation. Alan, we're short on time, but if you can kind of just sum that up really quickly, that would be helpful.
Yep, it's a 100-unit project, wood framed, built in the 1970s. It's on the island of Sanibel in Florida, and it got crushed in a hurricane 2 years ago. Water came in up 6 feet on the first floor, so they ended up gutting the buildings inside while they had it open. It's early wood truss construction. It's a fairly wealthy community, and the owners had been frustrated for many years over the noise transmission from the floors up, down, and they just researched, came to us and said, what can you do with this? And I said, I can make it quiet. And so they trusted us, put it in, just finishing the project now. The first tenants moved back in, or owners moved back in about 3 months ago. And they put a single sheet of 5/8 on the ceilings when I asked them to use 2, but they use a single, and they still got absolutely unbelievable performance. So they go in now, and they're running hammer drills, turning the TVs up as loud as they possibly can, and they've got no sound transmission whatsoever. The buildings are silent.
Yeah, that's awesome. Such an awesome,
extremely happy people. Yeah,
project.
So it works. So the idea is that it's a remodeling product as well as new construction.
That's right. So we have a few questions here at the end. I see from Adam, he said, as a residential custom home builder, I'm already sold on trying this out. Do you have, I'm assuming he means you, do you have any concept of installation time or learning curves? Who installs this? The framer, finish carpenters, drywall contractors? Let's start there.
Yep, framer installs it. It's really quick. So like a 12 by 12 foot ceiling, you'd have that in there in an hour to an hour and a half with the HushFrame and the wood furring. And at that point, you're off and running.
Excellent. Daniel asked about the installation details. We just showed the installation video. Hopefully, Daniel, that answered your question.
And there's a full guide also on the website, installation guide.
Absolutely. He said, do you have fire test reports that we can use for permit submittals?
Yes, of course. Yep.
Okay.
Yep.
He said, I assume that this product cannot be used in type 1 or 2 buildings.
It has been installed in type 2. But if there's a requirement where you can't have a wood product behind the wall membrane, then you would not be using it in a type 1, 2. No.
Daniel, did you mean IIC report for your next question? He asked, is there an ICC report for the floor ceiling assembly that discusses the ability of this product to support 2 layers of 5/8 gypsum board? And of course, the answer obviously is yes, because we've tested with 2 layers of gypsum, right?
It's always, yeah, we almost exclusively use 2 layers because of the extremely helpful performance acoustically, particularly in the IIC.
That's right. It looks like that's all the questions that we have. So if you need anything else, Bo's going to tell you something right now that I can't tell you because I can't remember the contact information.
Awesome. Thanks, guys. Yeah, if you have any additional questions, feel free to drop them in the Q&A now. We've got a few more moments left. There's also going to be a quick post-event survey as you're heading out from today's webinar. You can feel free to drop any questions or comments there. And then another great place to come if you've got some questions that kind of come up for you after today's event. I'll share this again really quick in case some folks were a little late joining, also because I was freezing a little bit in the beginning here. But everyone who signs up for today's webinar has a free Acelab account. You can use Acelab to search for any product or manufacturer. You just use the search bar right up here in the top. So if you type in HushFrame, that'll start to auto-populate. Head over to their page on Acelab. You can use this contact button to get in touch with their team directly. So you can come back here anytime if you've got some follow-up questions, you want to connect about a project. You'll get a record of that conversation stored on your Acelab account over here, right at the top with all your other account stuff. You'll also get emails about all of those messages, and you can reply directly to those emails. So you don't need to open Acelab's platform every time, but works really great as a way to kind of keep your communication organized along with your product research.
And Bo, looks like we have one more question.
Yeah, it does look like one came in. So you want to go ahead and talk about that?
Sure. The question, Alan, was, do we have, well, answer is yes, but do we have third-party independent lab reports? I already gave you the answer. Yes. Alan, do you want to say yes again?
Yes, we do. Quite a bit of it, yes.
Okay.
We're all about testing because that's the only way you know the truth.
That's right. In fact, I want to just share a quick story because I think this is really important. One day, Alan and I were sitting in the HushFrame office and we were looking up a specific product, which will remain unnamed. And on their website, in the fine print, one of the things it said was, "We have never tested our product due to the expense of actually doing testing." Do you remember that, Alan?
Yes, and it said that we passed the savings on to you.
Yeah. So that was nice of them to do that, but I thought that was a good story.
And they make the representations. Well, it's so bold-faced. It's remarkable, isn't it? Yeah.
It is. It really is.
Yeah. And actually, this all makes me realize another kind of great thing to share, because I notice a lot of folks are asking about like specific testing or installation files. So when you reach out to somebody on Acelab, we'll always ask you to nest it under a project, or everyone has a general research folder if you're just kind of doing some exploration. But we will also always ask you if you're looking to connect about a specific product, and then if you are looking for specific types of information. So if you want a price quote, if you want to get access to certifications, you can let the team know exactly what you're looking for here. Once you send that in, you can also go and type a little message to give some additional details about your request and what you're looking for. So that's a great way to come and, kind of tell the folks at HushFrame exactly what information you need and get any of the documents or resources that you might be able to use for your projects.
Bo, there's one more question that snuck in from M. Portis, who asked, any comments on the product's environmental product declarations or what happens at the product's end of life?
So, it lasts the lifetime of the building. So it's, we use a sustainable farm-raised radiated pine plywood that we import from Chile. And the pure silicone is an 100% RTV. There's no outgassing. There's no formaldehydes. There's no nothing in it. No petroleum base. It's just a pure silicone rubber, and it has a lifespan, of 100 years. It doesn't degrade. It's completely unaffected by atmospheric or chemical pollution. So it'll go the life of the building. If it's, I don't imagine you'd be recycling the stuff because you'd have to take it apart, but you have to just leave it in place.
Nice.
Awesome.
All right, great. It looks like, I think that was all of our questions. Looks like we've got to all of them here. So that's great. Just a quick reminder to everyone, there's some links in the chat if you want to grab any of those before you head out. And if you can give us some feedback on that survey as you're leaving, that would be super helpful. Thank you so much to everyone in the audience for coming out today and for asking so many great questions. And thank you, Alan and Micah, for a really excellent presentation. It was really great to learn some more about your product.
Thank you, Bo. We
Glad to be
appreciate you.
here.
All right. Have a good day,
Thank you all.
everyone.
You too. Bye-bye.